Okay, in this lesson, we're going to be talking about different types of variations. Now, variation is just a special relationship between variables. It's just, we've seen these in the past, they just have special names. A direct variation, general form is y equals kx. And anytime we have a direct variation, we'll say y is directly proportional to x or y varies directly as x. Now this is simple. This is a simple linear relationship. We've already done this. Y equals x is an example of a direct variation. Y equals 2x, y equals 3x. So we've dealt with these in the past. Now something I do want to point out, with a direct variation, you have no y-intercept. The y-intercept is going to be 0, so there's no number being added out there. Next up, a joint variation is just, it's also a type of direct variation, except for instead of, let's do a z, instead of y equals kx, you have z equals k times x times y or times y times x. Doesn't matter the order there. So you have 3 different variables involved. So it's just like a direct variation. In this one, I actually should have flopped those around so that it matches. It says y varies jointly as x and z. So y varies as x and z changes. So this would be a joint variation, or sometimes we might just say y varies jointly, or excuse me, y is jointly proportional or something to that effect. It means the same thing. Next is the inverse variation. Now, an inverse variation is, we've dealt with earlier, a reciprocal function, y equals 1 over x, is a type of inverse variation. And that's going to be y equals k over x, where k is some number. And this k that's in all these formulas is what's called a constant of variation. It tells how much does it vary. Does it vary by a factor of 2, by a factor of 3? So therefore, y equals 2 over x, y equals 3 over x. Y is inversely proportional, or y varies inversely as x. Okay, next, let's identify some of these. It says determine the type and then identify your constant of variation. So this is y equals kx, so this will be a direct variation, and our k value will simply be right there in front of the x, which is 2. Number 2, let me zoom in on all these. Number 2 fits the formula y equals k over x, so that'd be an inverse variation. And our constant of variation is the k value, which in this one is 24. Number 3, y equals 5 times x times z. So y varies jointly as x and z, so this would be a joint variation. And our k value in this one will be a 5, so it varies jointly. This one, x equals 3y, that would be a direct variation. And you can actually solve that for y. You can move the 3 over by doing x over 3. And I want you to get into a habit of knowing that that's the same thing as 1/3 x. That way you can see that our constant of variation there, if x is our independent variable and y would be dependent like it normally is, that would be a constant of variation of 1/3. Next one, x times y is 36. Now that looks different. Let's solve this for y by dividing by x, and you get y equals 36 over x, so that'd be an inverse variation. And our constant of variation will be a 36 there. Y equals, or y, 4/3 y equals, so let's get rid of that 4/3 by moving to the other side. To get rid of a fraction, we're going to multiply the other side by the reciprocal, so it'd be 3/4 xz. So you have three variables there, so that's a clear-cut joint variation. As you see the 3 variables, and our constant of variation would be the 3/4. Number 7 looks a little bit different, but we can get rid of the divided by x by simply multiplying by x. So you get y equals 2/5 x. That'd be a direct variation. Your constant of variation would be the 2/5, and you see there the proportionality of it as well, which is the reason we call it as proportional. Finally, this a value, I can move this 2 over by taking half, by multiplying the other side by the reciprocal. That way we can see that our constant of variation would be that 1/2. That would be a joint variation. And the constant of variation would be the 1/2 there. Number 9, now we're doing some examples of direct variations. Now, if it says as soon as you see y is directly proportional to x, that means that y is equal to some number times x. That's our basic direct variation. Now, what they're going to do is they're going to first give you an example. They're going to say when y is 28, x is 7. Now, what that does, that allows you to plug in and find out that constant of variation. So it gives us the example of, it says when y is 28, so plug that in for your y. The x value is equal to 7. Plug that in for your x. Into this direct variation formula. Solve that, divide by 7, and you get that k is 4. That constant of variation is exactly what it says it is. It's a constant. It never changes. So therefore, you now have a formula, y equals 4x. So then they're going to give you another scenario, and they're going to say, well, what about when x is this or when y is this? It says now find x when y is 52. So now what we're going to do is simply plug in 52 for our y, and we're going to solve that, have 52 equals 4x divided by 4, and you'll find out that when y is 52, that x would be 13. Okay, next one, number 10. R is directly proportional to the square of S. So you don't have a normal direct variation, it's directly proportional to S squared. So R is equal to some constant times the square of S, or S to the second power. And then again, they give you the scenario when R is 72, S is 12. So therefore, now we're going to take our formula and we're going to plug in 72 for R equals K times, we're going to plug in 12 for our S, 12 to the second power, that'd be 144. So that gives us 72 equals 144K. Divide by 144. Reduce that, that gives you that K is equal to 1/2. Now back to our formula, we can now take out the K and we can now put in the 1/2. We now know the constant of variation. So now we have a formula for this scenario, or for this entire group of equations here. So now they're saying find R when S is 8. So to do that, we're going to find R. So we're looking for R when our S value is 8. So we're going to do 8 squared is 64. So R would be 1/2 of 64, which is 32. So when S is 8, our R value would be 32. Next up, 11 is a word problem. It says the dollar amount D that Megan earns varies directly. So it's a direct variation. D is equal to some constant times, varies directly with the number of hours that she works. And that is true for any scenario. Normally, if you work so many hours, you have that constant rate. If you don't work any hours, now that's a key to all of these, that 0, 0 on all of these direct variations is going to be your y-intercept. If you don't work any hours, then you get no pay. So remember that. There's no y-intercept. In her last paycheck, now this is our scenario. She earned this much for this many hours. Now, what did that do? That tells us our constant. That tells us, we know that that's called a slope. We know it's a rate. So you can think of it as any of those. So the rate, let's take and plug those in to figure out that rate. The dollar amount that she earns, $148.50, is equal to the constant times she worked 18 hours. Mark that out, divide by 18, and we find out that our constant of variation is 8.25. So our constant of variation, 8.25, and we can go back and plug that in. So our dollar amount is going to be $8.25 per hour. So then what if then her next paycheck is $90.75? How many hours did she work? So we're going to take our equation. We're going to plug in $90.75. Then that will equal $8.25 per hour. Solve that equation by dividing by $8.25, and you get 11 hours. So H in that case would be 11. Now there's another way of working this. Let's go over that. Anytime that you have a direct variation, it varies directly. This is what we've called our entire mathematical careers proportionality. Anytime there's a direct variation, then you have proportionality, and you can set it up as a proportion. So let's take our first scenario. She earned $148.50 per 18 hours. How many hours did she work, X, down here, if she earned $90.75? That's a proportion. She earned $148.50 for 18. She earns $90.75 for how many? And these are the only ones that you can set up like this and work as a proportion, you can multiply these two, divide by 148.50, and you get that same x equals 11. Okay, number 12. Now we're dealing with joint variations. You work these the exact same way as we did with the equations earlier. If y varies jointly with x and z, you have y varies jointly, so that means that you're going to multiply x and z together to get it. And then it gives you a scenario. It says when y is 48, x is 8, and z is 15. So plug all that in. So y is 48 equals k times x is 8 and z is 15. Multiply that 8 and 15, you get k times 120. You will then divide by 120, and that gives you that k is equal to 0.4. So therefore, let's go back to our equation, and we now have our constant of variation. 0.4 times x times z is now our equation. And then they say, well, what about in this case? Find y when x is 14 and z is 20. So to find y when that happens, we simply leave our y in there. 0.4 times our new x value. What about when x is 14 and z is 20? We're simply going to multiply all this together, and we get y would equal, in that case, 112. Number 13. It says P varies jointly as Q and the cube of R. So P varies jointly, that means there's your constant, as Q and the cube of R. Don't get that mixed up with the cube root of R. So Q and the cube of R. And then it gives us our scenario. Let's plug all this in. When P is 270, Q is 6, and R is 3. So P is 270. We don't know our constant. Q would be 6, and R would be 3. So that'd be 3 to the third, which is 27. Gives me 270 equals K times 162. When you divide by 162, you're going to get K has a value of 1.6 repeating. So it's just a little bit uglier to plug in. However, up here, you can come up here and take out instead of rewriting the whole thing, you could just plug in 1.6 repeating there. Now that would be 1 2/3. So if you'd rather plug in 1 2/3, you could write that as 5/3 as a fraction. That'd be a little bit cleaner. Then it's going to ask us for this scenario. Find P. So we're going to leave our P. We're going to leave our 1.6 repeating when Q is 3. So we're going to plug in 3 for Q. We're going to plug in 5 for R, and I'm going to go ahead and cube that, so 125. So we're simply doing 3 times 125 times 1.6 repeating. And the way that I do that on a calculator is I'll just type in 1 point and put 5 or 6 sixes. Put several sixes there. Just kind of fill up your screen, and you're going to get P is equal to, and it actually tells me that it's equal to 624.999998, and that's the reason, because I didn't actually use 1.6 repeating. The actual answer is going to be 625. Okay, next problem. It says for Tom's savings account, the interest earned varies jointly with the principal and the amount of time in years since opening the account. So the interest earned, we'll call it an I, is varies jointly. So our constant variation with the principal, we'll call a P, and the amount of time in years since opening the account. So there's our formula. It says if Tom opened an account 3 years ago, there's your T, there's your principal, and there's your interest. How much interest, and then they're going to ask us another scenario. But let's go ahead and find our constant of variation by using what they gave us. We earned $144 in interest. We don't know the constant yet. Our principal was $1,200, and it was 3 years ago. So we're going to multiply 1,200 times 3, which is 3,600, and we're going to divide this side by that 3,600 to find our K value, and we find out that K is equal to 0.04. So that'd be an interest rate there. And we know that this formula looks familiar now. Interest equals principal times rate times time. So this is a formula you've seen before. So therefore, now they're going to ask us how much interest will he have earned 8 years after opening the account. So we're wanting to know how much interest will he have earned 8 years. So it gives us a time, but it doesn't give us The principal, well, it's the same account, so the principal is still going to be $1,200. So our rate is 0.04. The principal, again, we said was $1,200. That's how much he initially invested. And we want to know how much will he have earned in 8 years. We simply multiply all this together, and we get that the interest would equal $384. Okay, now we're going to be talking about inverse variations. If y is inversely proportional to x, again, there's your inverse variation formula. Then it gives you a scenario when y is 7.5, x is 8. So therefore, we're going to take and plug in 7.5 for y, and we're going to plug in 8 for x. To get rid of the 8, we're simply going to multiply by 8, and we find out that our k value is 60. So go back to your original. Now let's plug that k value in, and you now have a formula, y equals 60 over x. Then they're going to say, okay, then find x when y is 5. So we simply take our formula. We're going to find x when y is 5, so plug in 5 for our y equals 60 over x. Now, how do we solve this? A couple of different ways. You could put 5 over 1. You could solve it like proportion. 1 times 60 divided by 5, you get x is 12. Another way to solve it is you could flip both sides. That'd be 1 over 5 equals x over 60 and multiply by 60. 60 divided by 5 still be 12. So several different ways you can work it. This reminds me a lot of, though, when I deal with trigonometry, when we're doing sine equals opposite over hypotenuse, and you're having to solve one of those. And the trick I like to use is just take this value, and they can interchange. And x would equal 60 over 5, which gives you that same answer of 12. Next up, number 16. M is inversely proportional to the square root of n. It's an inverse variation with the square root of n. Let's take your scenario. M is 27 when n is 16. So therefore, you have m is 27. We don't know our constant. N is 16. The square root of 16 on bottom is 4. To find that constant, multiply by 4, and you get 108. So therefore, your formula is now m equals 1 over 8 divided by the square root of n. Then they're going to ask you a question of what about in this scenario? Find m when n is 64. So therefore, you were looking for m equals 108 over the square root of 6, which is 8. 108 over 8. You can divide that out, and you're going to get 13.5 or 13.5. Okay, next problem. We have, again, a word problem. Let's scroll over. The time it takes Adam to drive to Disney World varies inversely with the average rate of speed. So speed goes up, driving time goes down, and vice versa. So the time it takes varies inversely as speed. We'll call it velocity. Time is equal to k over velocity. This also looks like a familiar formula. If it takes Adam 10.8 hours at an average speed of 50 miles per hour. So let's plug that in. It takes him 10.8 hours equals k over when the velocity is 50 or his speed is 50. We can do times 50 to figure out what our k is, and that would give us a k value of 540. And if let's go ahead and plug that k value in. So it'd be time equals 540 over v. Now we're going to say, okay, what if he drove 60 miles per hour? Then how long would it take him? How long would it take if we average that speed? So therefore, the time at 60 miles per hour would be 540 divided by 60. That time would be 9 hours. If you don't recognize this formula, this is actually your distance equals rate times time formula, or distance equals velocity times time. So this is actually a distance on top here. Now finally, we're going to talk about combined variations. A combined variation is a relationship that contains both direct and inverse variations. It has to have both. So anytime it says y varies directly as x and inversely as z, so you have directly as x, so we're going to go ahead and do our constant here, and then anytime you see that word inversely, it nearly means divided by, so inversely as z. And you can think of it as before when we said y varies inversely as x. We did divided by x. So anytime you see that inversely, think division. So that would be that scenario. P varies inversely with Q and directly with R cubed. So you have it varying directly. I'm going to do the direct first, directly with R cubed, like that, and then inversely as Q. So there's your scenario. And that was actually supposed to be Q squared. It varies inversely, so we're going to divide by Q squared. We're going to multiply by R cubed. Pretty much is what it's saying. Directly, we're multiplying. Inversely, we're dividing. So now, number 20, A varies directly as B. So you have a direct variation. You're going to multiply by B, and then inversely as C, and you don't have to put two constants of variations. It works itself out. You don't have to do divided by KC. It's going to work itself out. So there's our formula. Then it gives us a scenario. A is 16, B is 12, C is 6. So let's plug all that in. A is equal to 16. We're looking for our constant. When B is 12 and C is 6. Now notice that the K times 12 on top, that's a single term. So you could actually cross those out and turn that into a 2. Divide by 2 and you find out that K is 8. That's a whole lot quicker. You could do it. You could multiply by 6, divide by 12, and do all that if you would like to, but that was faster. So our formula is now A is equal to 8B over C. There's the formula. Now let's find their last scenario when B is 28 and C is 4. Find A. So A is equal to 8 times when B is 28 and C is 4. And again, if you would like to, you could cancel these out. You could cancel those out, or you can cancel these out. It's just like cross-canceling. We'll cancel the 4 and the 28, leaves you with 1 and 7. So therefore, you get A is 8 times 7, which is 56. You can multiply it out and do it the long way, but that was much faster.